Greetings, building science enthusiasts, and welcome back to our podcast. This episode is brought to you by our dear friends and colleagues over at Risinger Homes. They're an Austin-based, full-service luxury home builder and remodeler, and we've worked with them on many occasions. And Risinger Homes really is a different kind of firm. First, they're focused on building science, which we think is incredibly important, and I encourage you to check out the YouTube channel of their owner, Matt Risinger. It's at youtube.com/user/Matt Risinger. Be sure to subscribe. And secondly, we've seen time and time again how much architects really appreciate the seamless experience of working with a builder who has an in-house architect/builder. Risinger Homes has exactly that person. His name's Eric Rouser. So architects, call Risinger Homes early in the design phase of your projects so we can team up with you and your client to build a great home.
Welcome to the Building Science Podcast.
Bringing the human factor to construction, design, and architecture. Brought to you by Positive Energy in Austin, Texas.
Okay, hello and welcome everybody. Welcome back to another episode of the Building Science Podcast. I'm Christoph Irwin, your host, and today I have two guests. The first that I'm going to introduce is Matthew Tanteri. Matthew is on a mission to bring natural light, view, and comfort into buildings through the establishment of a collaborative alliance with HLB Lighting. Matthew provides thought leadership with their daylighting and sustainability design studio. He also manages the daylighting and electric lighting of a number of large commercial and institutional projects. Meanwhile, Tanteri & Associates, his globally renowned namesake firm, continues producing creative and technologically innovative light projects that include LED media facades, towers, luminous tensile structures, and light art. And I would also add, Matthew, that I think you had something to do with some rock and roll show lighting way back in the day.
Right. My past history is that I used to provide laser displays for lots of bands.
Are you allowed to say any of the ones?
Oh, yeah. I toured with Def Leppard.
All right.
Did a show with Kiss.
All right.
Michael Jackson.
Oh, really?
Earth, Wind, and Fire.
All right.
I mean, I if I start thinking, I will just keep going.
That's a lot. And he's young and spry in spite of that background. So Matthew's also a fellow with IES, which is the Illumination Engineering Society. Hint, that's a big deal. Plus many other credentials, which would take too long to go through. So now I'll introduce Keith. Sorry, Keith, you're going to seem small in relation.
Hi, everybody.
So Keith Simon's been with us before. You guys might remember him. He's a senior architect and building enclosure consultant at Building Exterior Solutions here in Austin. And BES has recently become a division of Terracon, so congratulations for joining Terracon, Keith. Keith and Matthew, actually, are also both adjunct faculty at the UT School of Architecture. And I welcome you both, and let's get started. I have a couple of things to say. So just for bookkeeping, you guys listening, this is one of the podcast episodes that is on our indoor environmental quality, our IEQ series. This one is about light, so this could be considered the ILQ series for episode. And today we're all going to be having a discussion about light and lighting and the quality and quantity of light in a space, its composition and interaction with us and our surroundings is probably one of our dominant experiences of the world. If you're listening and not driving, go ahead and close your eyes for a minute and see how everything shifts. Just thinking generally, the current trend of ever-increasing window-to-floor area ratios, it's absolutely related to occupant experiences of light and view and connection with nature, and like Matthew's mission to bring natural light and view into buildings. And then there's, recently LED lighting and screens are sort of changing the way we interact with light. Like, think about how much of our time is spent with our eyeballs on screens and indoor with electric lighting and how that impacts physiology and psychology. So with that, I'm going to turn it over, and I guess, Keith, would you like to start with that?
Sure. And one thing I'd like to add is that not only are Matthew and I both on the adjunct faculty at the School of Architecture, but for the past 2 years, we've actually co-taught a class together called Environmental Controls. It's a large undergraduate class that covers electric lighting, daylighting, acoustics, and introductory electrical systems. So that's been a pleasure. And something else I'd like to also add to Matthew's resume is that I want to point out for people that he's not just an electric lighting designer and consultant, but also a daylighting designer and consultant. And that combination of being able to consult on both electric lighting and daylighting is very unusual and incredibly valuable. So it's been a pleasure to get to know him and teach with him over the past 2 years.
Thanks, Keith. I think that daylighting focus will come out as we talk, because I tend to go there as we talk about the subject of light.
So I was thinking we could start our conversation by paraphrasing David Foster Wallace, where he tells this story about two fish who are swimming along, two sort of young punk-like kid fish, and they're swimming along, and then an older fish is swimming the other direction, and the older fish says to the younger fish, how's the water today? And the young fish kind of look at each other strangely and just swim on. And then when they're out of earshot of the older fish, the two young fish look to each other and they say, "What the heck is water?" And so I love this story, and I think about it a lot. And I think it's an analogy that we could think of when we're thinking about how light and architecture interact. That in one sense, light and architecture cannot exist separately. They are one and the same, and we can't experience without light. Yet at the same time, it's frequently forgotten or put down on the priority list. And I guess what I'd like to open up the conversation with you is, how do you perceive the world of lighting design in our building industry? In other words, it's divided between professions, architects, engineers, designers, and it's divided into metrics. And how sometimes do you feel as though the sort of importance of this subject is not always given the understanding or importance that it deserves?
Okay, so I'll approach the questions you asked from both ends. For the last question, I don't feel that it gets the importance that it deserves. However, I am finally starting to achieve one of my goals, which is to work with architects at the very beginning of the design process to shape the building, to bring in natural light as the first thing, and then design electric light around it, because that's the proper way to do it. Mm-hmm. So that was a goal of mine for 2 decades, a decade and a half at least, and finally I'm there with the right clients and getting measurable results, like simulation agreeing with built construction. So it's just to go back now to the beginning, have the way you started with the fish story. So I would take the literal translation of that the water is light and the bowl is architecture, right? Because then you go through your day, you walk around. Well, if you're in nature, it's very hard to walk around without noticing light. Just because if it's variegated, it presents itself in layers. There's spectacle in every glance, in every vista you set up. Whether it's and that's nature. That is our connecting experience. However, when you're in the interior of a building, which unfortunately we spend most of our day in interiors of buildings, you don't have the same spectacle of light that you have in nature. So it does become like the fishbowl in that there is less asymmetry or spectacle or let's call it a random organization that keeps your senses stimulated. So maybe we have more. All right, so that is sort of the hard part, is creating an interior that keeps your senses stimulated, that there is a relationship to nature, yet you perform your task and you stay on this edge of stimulation and focus on what you're doing. I think that's the hard edge to ride. That's what I get to with quality. We have to be in that zone of comfort, stimulation, and be able to go in and out of it. But let's also look at that fish story that Architecture is the water, where you don't even notice architecture anymore, because if it's so regular, if lighting is not distinguishing it, then there's nothing to hone in on. Like, say, a wall. If there's a wall that is of a material that a lot of money has been spent on that material, if there isn't light on it, that wall doesn't come into prominence. It doesn't pull your attention. So it becomes like the water in the fish story, that there's no, oh, did you see the wall? Well, what wall? I mean, I was walking around, I was thinking about this, what I got to do in the next 15 minutes. Nothing brought you to that wall. The architect may have designed the building as a funnel, where he funneled you right to the wall, but you were looking at your phone, man, because you got work to do. So that wall never happened for you. So, I like the fish story, that, coming into it. I'll also just add, like, the frog story, which is, you've heard, you put the frog in the water and you heat up the water. The frog never notices and just boils to death. Well, that doesn't happen with people. You put them in a pot of water and you start to raise the temperature. Now let's call that the pot like a building, and you're letting sunlight into the building, and you're saying, okay, you're going to work in this environment with sunlight coming into the building, lots of glass,
Actual fishbowl.
and you're going to be productive and give us the most return on our cost per square foot. It doesn't happen. Buildings don't respond the way the body does. They don't automatically blink their eyes and open them when the sun's not there. They don't adjust climate the way the body does, right? They don't get up and move, turn around, or go to another location. So we're different creatures, right? We have to think in a different way. We have to design buildings that are able to respond, and if we have to make decisions about them. So getting back to your middle question, not everyone does that, right? You need someone who's thinking on several levels of light and heat and architecture, and it's not something that, because my clients are architects and engineers, I'm not putting any profession down, because it's all a collaboration, but you need someone focused on that role. So that's my role as a lighting consultant, is I look at light, I look at daylight and electrical light together, and architecture, and I stay focused on that through the design process, because I understand how important they are to the qualitative experience of space and worker productivity, which is a concern of the owner.
Yeah. So this you brought up this idea of the wall kind of fading. You don't see the wall, and I think it's important to note it's not just because it might, if the lights are off and it's dark, you don't see it, but that there's a homogeneity to it, that it's not illuminated, you don't notice it. And this goes into sort of the drive between variance versus homogeneity, that in life we do prefer some variance, that it's soothing to the eye when there's some natural light or controlled natural light, that we see the changes in the cloud cover overhead, or the illumination may increase a little or decrease, that's pleasant for us as human beings, and that sometimes there's a drive within architecture for homogeneity. In other words, dropped ceilings, all acoustic tile ceilings, all beige surfaces, all absorptive material, all gray carpeting, with the idea of having the sound and the light completely homogeneous, completely even. And that unfortunately that drive for controlled environment sucks the life out of a building. And it makes it absolutely a terrible place to live or to work or to inhabit. And yet the other extreme is no good either, right? Like the other extreme is we do walls of glass. And we have walls of glass maybe because we're in love with the floor to ceiling glass and the sort of architectural element of that, or whatever it is, but it also brings in too much light and too much glare and too much heat gain. And so these extremes of too much or too little are just no good, and that daylighting is really, that's the hard part, right? It's getting that balance of not too much and not too little, but getting it just right, somewhere in between.
Right. So some of the things we've taught in our class, let's go more into what you just brought up, which is there's layers of light in any visual scene, just like in musical composition. There's layers of instruments and tonality. Let me stick to light. So in light, when you deconstruct a scene into layers, there could be, let's call, we can use, Richard Kelly, the great lighting designer who worked with Louis Kahn. He had a great philosophy of light that there's 3 components. There's ambient light, there's points of light, and focal glow. So, he had specific words. There was play of brilliance was the sparkle, with little highlights. Focal glow was like a pool of light that brought your attention, like standing around a campfire. Mm-hmm. And ambient light was like, say, a indirect lighting, an overcast sky. So in your examples you brought up, if we felt that if we illuminated architecture so it was an overcast sky inside, eventually we'd get very bored with that diffuse lighting, shadowless light, mm-hmm. right? And then if we put large glass walls, if we lived in glass boxes, we would have, I'd say, points of light. We'd have the sun coming in, sharp shadows. There'd be no relief for us to look away from. And then that focal glow would happen when there's sun patches reflecting on the floor, and we could go near them, and they're actually nice, right? They're nice. As long as you are not in the patch, you can control your location to them. They're actually light sources. They're our lamps. But so viewing that condition in those layers of light, what we want to have is we want to create these daylighted spaces that have these varying mixes of these layers of light that stay in controllable situations that keep us comfortable, that we stay comfortable thermally and visually. When you started off, you were talking about, I know, Keith, you want to talk about the roles of different people, but we can talk about architects, engineers, and designers, like what the roles are for them with indoor environmental quality. What are the metrics?
Yeah, maybe now's a good time to give maybe an overview of what are the most common metrics that are used to design light for spaces, and then also maybe some color commentary on which of those metrics, if they're doing a good job or not doing a good job, or what metrics may be coming down the pipeline.
Okay, so as you said earlier, I'm a fellow of the Illuminating Engineering Society, which publishes all the standards for the profession that make up the best practices of light and design in architecture. Now, it's called illuminating instead of illuminating. And here's one of the big distinctions, is that illumination is light incident upon a surface. So recommended illumination, what's the standards that are published are recommended illumination levels, the amount of light that should hit a surface for us to perform a task. Now, that doesn't say too much about what we see, because it's energy before it interacts with the surface. The surface has a reflectivity, a finish, a color, and it's that interaction is what we actually perceive. And most of those illumination recommendations are on a horizontal surface. And again, that doesn't really equate to what we see, because we mostly see vertical surfaces, right? You walk in a room, it's not the floor that hits you first. It's like the walls, it's the windows, it's luminance. It's not illuminance. So the typical metrics...
So what's luminance?
Okay, luminance is light leaving a surface. It's the interaction of illuminance and, if it's an opaque surface, reflectance. And then those two multiplied by each other produce luminance. And depending on the surface, the luminance can change over the angle that you view the surface. If it's a perfectly diffuse surface, you got this perfect luminance as you go around, as you look at different angles at the surface. But if there's any if there's any specularity or spread to the surface, it will vary by angle based on the incident angle.
So the overcast sky, that was a diffuse light.
Well,
you said that would bore people.
Okay, so there's two types of luminance. There's reflections of light incident on an opaque surface, but there's also then luminance through a a translucent.
Well, for
surface.
example, those curtains there in your living room has a nice soft glow coming out of them. Right. And what that is the exterior light, the sun, or the reflected light from outside is filtering through that. So what we see is the transmitted light through that surface. And for those listening, like a curtain or a shoji screen. So what we actually see is the luminance, and it can be light that's filtering through, transmitted through a material or a surface, or it can be the light that's reflected. So when we look at this table here, we're not seeing the light that's falling on the table, which is illuminance. We're seeing the light that's being reflected off of it.
Now let's throw another thing in there, which is we don't all see that light. We see what we finally get interpreted as the image is the light that reaches our retina, which is very different for all of us.
Because we're in different locations and our eyes are different.
Our eyes are different. Our age is a big factor, right? You need, for a 20-year-old compared to a 40, 50-year-old needs, like that 50-year-old needs about 4 or 5 times the amount of light to see the same as the 20-year-old.
Wow.
Yeah, so imagine that, like being in a room with a 20-year-old and a 50-year-old, well, and a 1-year-old, how they all see things differently just based on the amount of light reaching the retina.
Yeah.
Then we all have
Colors.
Life is beautiful, but for the eye, the eye ages, and as the eye ages, that beautiful clear fluid in it gets a little more coagulated and yellowish and starts to tint the color of light, absorbs wavelengths. So that also impacts the colors we see as we get older. I didn't know. So our sensitivities to color changes. So not to get down that road too far, the point is that the person, it's themselves as a camera, it's the light that registers on the retina, which could be different for all of us as well. So just let's go back to the question, which the basic metric is illuminance on a horizontal surface for light. All right. And that's really for things where, say there's a lawsuit. Oh, I slipped and fell on your stairs, and now the person is suing the owner, and they're like, okay, well, what was the light level on the stairs? So you would look at what's the best practice and see if you have those illumination levels and maybe the contrast of the steps, and so that if light played a part in the person slipping, but based on illuminance. All right, so then energy codes don't look at illumination. They look at power density, the amount of power in an area, either it's a foot or a meter squared. And the reason why is because energy codes are driven by energy conservation. So now we're not looking at anything qualitative, we're looking at something quantitative. There's a corollary between illumination and energy and power. I'm not saying energy yet, because of the efficacy of the source, how efficient the source is at converting energy into luminous energy. Is efficacy, lumens per watt.
Right.
But so that will vary by source. But the basic metrics are energy codes look for power in watts per meter squared or foot squared. Lighting looks for illuminance in foot candles or lux. And then there's another order of metrics after that, which is more addressing qualitative things. Luminance, which we started to talk about. And then for the power, there's energy, looking at power over time, which would start to be energy.
Right.
And that's where controls comes in. Like you could have a lot of potential, you could have a whole building go on and be a great amount of energy, but really with controls, there's never a time everything comes on full. It comes on slowly, you can have a lot of variety. So thinking of those, those are another layer of metrics to fully describe the energy consumption and qualitative aspects.
So I also want to add in there the element of time, which is that our eyes are always adjusting to the scene and the contrast in the scene and the light levels in the scene. And so everybody has the experience of you go into a dark movie theater and at first you can barely see a thing, but then you give it a minute and you can see pretty well. Or the opposite, you're in that dark theater and you go outside and it's almost painful, but then you give your eyes time to adjust to the scene and it can handle a certain range. And so I feel like maybe it's because of our rushed society. Sometimes we don't give our eyes that time. And as an example, when I give presentations in, say, architecture firms or industry locations, I want to turn the lights down because once everyone's had a chance to adjust with their eyes, they can see the presentation better. Yet at first, people don't want to give it that chance, and actually I've had a number of presentations where everyone who comes in flips the lights back on, and then I have to turn them back down, and then they flip them on. So how do you account for the element of time and adjustment? Does that come into play when you do lighting design?
Yeah, because you can't separate space and time. We're slaves to it. But it's a good thing.
You're talking relativistic physics now?
No, I'm going to stay away from that. Because we can have a separate conversation about that. I'm just going to talk about buildings. There's a very formal, the partie of a building. There's a concept, but there's a spatial progression. There's an exterior, there's a vestibule, there's a corridor, and then there's a room, right? So it takes time to go from the exterior to the room. Now, I think a museum is probably a good example of that. Or a theater, where you come, it's bright outside, and now you're going to go see this beautiful watercolor that has, let's see, if it's a sunny day outside and it's 10,000 foot candles, you're going to come in eventually and see a beautiful watercolor lit with 5 foot candles. Now, what percentage is that? I won't calculate it.
It's a lot.
It's much less than a percent.
0.002.
However, our eyes adapt. They adapt over 14 orders of magnitude.
Wow.
That is an amazing visual system. Mm-hmm. So the way we make that happen is the time it takes to go from outside to this room. You, as an architect, you would design the space to make sure there's enough time for your to go from daytime vision, photopic, to some type of close to nighttime vision. It takes a longer time to get into scotopic, but mesopic, which is in the middle, so that by the time you're in that room, you're seeing the 5 foot candles looks like 10,000 did outside. Not quite, but you would get the same stimulus of the contrast ratios in there, even though they're so different. So, and that's something really that, we just, another thing when you call the light is water, you don't notice it. You don't notice your eyes doing this incredible adaptations that it does from, being outside in full moonlight.
What were those terms again? Would you mind it sounded like it was a human physiology. Photopic?
Photopic is daytime vision.
Okay.
That's when the peak sensitivity of your eye is around a yellowish, greenish wavelength.
Okay.
I'm not going to give numerical wavelengths because they won't mean much. So we're sensitive to yellow-green.
Mm-hmm. That's the center of the sun, really. And reflections off.
Well, our eyes evolved on the Earth. I'm sure there's a reason why yellow-green peaks. Mm-hmm. When I'm hungry, I'm looking for green, right?
Yeah.
So our eye evolved to see this peak wavelength for a reason, which I think has to do with evolution, survival. And then at night, it goes to bluish. It shifts towards shorter wavelengths, bluish. So so if you were...
There's a name for that? Scotopic?
Scotopic. And then there are states in the middle called mesopic.
Okay.
And it takes time.
Interesting.
Yeah, so now those different ways of seeing, the illuminance metric is based on daytime vision. So what happens at nighttime vision?
Right.
So now there's a way to readjust daytime vision levels to nighttime vision levels. You can overlay this method onto the prescribed illumination levels and come up with some adjustment based on wavelength content. So now it gets layered.
Well, I do want to point out that this is, I believe, a really important part of sustainable design, that the ability to design for how we as humans experience a space and how our human eyes adapt. Like you said, you can design a space where you can safely and positively view a work of art at 5 foot candles. But if we rely on the energy code or the illuminance, the metric illuminance, the illuminance guidelines, they'll say we need 50 foot candles. And so that's where I believe the real sort of art and potential of the lighting designer comes in understanding that experience. And so there's the element of time and the element of contrast. And so the contrast goes back to this idea of homogeneity versus variance. And, if we rely on these guidelines of, say it's a classroom for students, and we must have 30 foot candles or 50 foot candles throughout, then we're filling up this volume of light. And even if we use really high efficacy, energy efficient light sources, there's still a certain critical mass of energy required to fill up this volume. But if we can design where we're okay without homogeneity, like for example, perhaps lower light levels around the corridors or between desks, or maybe the front board is at a higher level but a lower level on the lights. If we can design for that contrast, that is an element, a potential of sustainable design and energy efficiency that goes way beyond how many lumens per watt.
Right. So, okay, so I got that stimulated a lot of different thoughts, but and we've talked about this in our class, as we've taught our class. So if you're a lighting designer, there's many strategies to creating a lighting design. So one of them could be, instead of supplying a general illumination level with the fixtures that they all go to 30, you could have pools of lighting that are much higher in the space. And I'll give you an example. Like in high-end retail, you highlight objects at a high light level. Now the reflected light from those objects give you this 30-foot candle base layer of illumination. So now you can get to this average level using pools of higher intensity. And so instead of illuminating uniformly, you've illuminated maybe asymmetrically at high levels with high reflectance surfaces and hit your target anyway. And now it's a more interesting environment. It's just a lighting strategy. Mm-hmm. And there's others for that. There's other strategies to get at similar things. And that the other point you made about light over time, there actually is a whole body of metrics around that. And I'll just go back to the museum example. When you look at artwork in a museum, the metric is lux hours, so that you multiply illumination level over time, and that gives you a final metric that tells you that you can relate to the sensitivity of the artwork and understand how long it will take to be destroyed, because every artwork is fleeting. It's just they all go at different rates.
And lux is the more lux it destroys.
Lux times, yes, over time. So
lux is like a lighting power.
Lux is the same as illuminance. It's like foot versus meters. It's what the rest of the world uses.
Oh, okay. So in Europe, it's not the Illumination Engineering Society; it's the Lux.
No, they have their own society, but they use lux, which is based on the metric system, and we use foot candles based on the British system.
A rule of thumb is it's about a factor of 10. So 10 foot candles is 100 lux, approximately. Is that right? Or did I go the other way?
No, that's right.
All right.
You know what's nice about the foot candle is, a foot candle is if you took a candle and lit a candle and you held 1 square foot, 1 foot away from the candle, that's a foot candle. Mm-hmm. So it's if you need to just get a reference point,
exactly.
You can light a candle.
There's a physicality to the name.
But for the so making the analogy of how many lux hours do people need, that's interesting, because our eyes do also, our retinas deteriorate over time, and that's why we watch out for UV, high levels of light. So we similarly, our retina also goes over time. I don't know if we all are aware of that, but that's why, especially for like Austin here, sunglasses, staying away from UV exposure.
Well, I was really hoping you could talk about, since Matthew spent a good part of his career in New York City doing lighting design and daylighting design, and then moved to Austin, Texas. Could you talk about some of the well, obviously we have a lot more daylight hours here, but designing for visual comfort, I assume, is some very different strategies here in Austin versus New York. And if you could speak to some of those.
I just remember when I first got here and I just could not make it from the car to a building without sunglasses and squinting. I didn't have a pair of sunglasses that were dark enough.
Interesting.
And it took me months to get used to it. And even for my kids, I would see them just standing there in the parking lot, not knowing what to do because it was just so bright. So now, light levels are a little higher here, but it's really that more ground, less obstructions, that brightness of, let's say, 10,000 foot candles on a 60% ground is just, the luminance from that is equivalent to a cumulus cloud, right next to the sun, illuminated by the sun. So again, when we talk about this experience, I'm going to use nature, that nature can, what's the next thing, after the sun, what's the brightest thing? It's a cumulus cloud in the sky.
I didn't know that.
So
I thought it would be the full moon at night.
No, or snow. Well, the luminance of the moon tells you its reflectivity. It tells you, that's how they figured out what the material of the moon was, by the luminance, because it starts to understand the reflectance. But so what I noticed was the brightness, of course, the amount, the insolation, like just sunlight hitting your flesh, how hot it is, and maybe that's angle related.
And that was, just to reiterate, insolation, not insulation.
Right, insolation, just radiant energy hitting energy radiated from the sun, so coming like incident radiation projected from the sun, hitting your skin, and you converting that. You're without seeing it, you're converting it into heat on your skin, like feeling it as heat. So that was the sensation I'm talking about. So those physical things, but then, my architecture design side, it was unbelievable to me how poorly shaded this area is. How I thought I was going, when I made the journey from New York to here, I thought I would see a very sophisticated use of shading devices, and I haven't yet. Mm-hmm. I've seen over-glazed buildings, and I haven't seen... I've seen overhangs, but nothing really thought through. Mm-hmm. More as decorative features, or just the borrowing of vernacular devices without tweaking, optimization. So that constantly surprised me, especially on larger buildings, or buildings where it makes a big difference monetarily and just for the quality inside.
Yeah. Oh, absolutely. I mean, we can walk around downtown Austin or in the neighborhoods and look at shading devices, fins on the south side, horizontal on the east side, and too far, too shallow, too spread out. Just the wrong strategies used as aesthetic elements, but not performance elements. And then every once in a while, we see one that's done right, and it's like, hey, they got it. And it's a little frustrating that it's not more ingrained in the vocabulary of the local architecture. I definitely agree with that. If we go to talk about energy efficiency and sustainable design, there's, I think, a lot of layers to that within lighting design. But to start from the most basic building block of a light source or a light bulb, and we look at energy efficiency, we call it efficacy, lumens per watt, how much light per unit of power we get out of a light source. What are some of the trends, the technological trends, and where do you think they're going?
Okay, so today, when you say technology, it has something to do with LEDs, because LEDs took the lighting world by storm. Yeah. It started about a decade or two ago that LEDs started to get used in architectural lighting. But it was only just 2 to 3 years ago did they get up to a level where they just took over. I mean, now it's rare that I have a project where there's something else other than LED on the project. And that other thing is usually fluorescent, a linear fluorescent, where it has the similar efficacy to LEDs, but the reason why it's still used is because it's lower cost. Like one of the prohibitive factors of LED usage in the beginning was they were very costly, but then the price just started to drop and drop. So that's how they took over, being replaced for other sources. So, but there's still places where fluorescent is cheaper than LED and does a fine job. When you need high luminance levels, dimmable in a large space, and the form factor works. Like the LED form factor doesn't necessarily give you anything better. But so technology is, I would say, it's LED related. It's around the miniaturization of LEDs, the form factor of LED fixtures, that because of its just unusual different form as a source, the fixture around it has changed so much that it looks cool. There's cool things that you can do with it. You can have waveguides, like a glowing slab can be your illumination source. It's edge lit with LED and be very thin. Or you could have very small little cuts in drywall that you can hide LEDs in the thickness of drywall and glow and have some usable illumination besides just seeing a cool knife edge effect. So that, and you could put it close to a person and supply task lighting, whereas with other sources, you wouldn't want to put that source that close to a person. It's just too much, too bright, too big. Right. LEDs, I mean, you're starting to get them really close to your body, and so you're not, you can get them local, like for local task lighting. So you can supply a person with that level of light they need, but you don't have to light the whole room necessarily. So like for that localized lighting, it works really well. They are still... Their efficacy is up there. I think they're leading the efficacy now of all the sources. Fluorescent, it's not that the other sources are way behind them. They're right there. I mean, they got to the top of the efficacy level of sources with, I'd say, compact fluorescent and metal halide. But I think they started to just exceed it. So, we've really pushed LEDs to
what about lighting quality? I still find there's quite a range. Like if you go to Home Depot, for example, you can find LEDs with good lighting, warmer lighting quality, but a lot of them are still sort of like a nasty green or a nasty blue.
Well, that's a big problem because LEDs produce light in a different way than an incandescent bulb. An incandescent bulb produces light by a glowing tungsten filament incandescence like the sun, which gives you a very continuous spectrum. You have all colors. There's nothing missing in between colors. Continuous. LED produces light by line spectrums. There's individual wavelengths that produce energy. And then it's the combination of those particular colors that give us the impression of white, whether it's cool white or warm white. If there's colors that are deficient in the spectrum, we just don't see them. So if you have something that has a color and that color is not in the source, you don't see it. And that's when things start to get, when you start to feel cheated with light, where something looks great in one outside, suddenly you bring it and you look at it with some source, let's say it's an LED source that's missing the greenish one, and it just doesn't look good, or it looks strange. So there's new metrics that, like, LEDs has forced the study of new color metrics that had to come out to address the particular idiosyncrasies of LEDs. So there's new ways of describing color because of LEDs. Yeah, there's been new... So as an example, for color rendering index, which is a value from 0 to 100 that describes the rendering ability of a source, 100 being daylight, or an incandescent lamp, 100. It was based on you looking at 8 swatches of color, pastel-like colors, and how those colors rendered compared to 100 would be a numerical rating that would convert to excellent, very good, good, acceptable, poor. And LEDs, because of the particular way color was produced with different line spectrums, didn't equate those 8 particular colors didn't reflect the way an LED would say render red. So they had to add more colors. So they expanded the color chart. So, but there's so much more. There's 4 more new metrics just for color.
I got a quick tie-in on those LEDs because you said it's a big problem with LEDs, and one of the implicit big problems with energy efficient sources generally is this unfortunate public perception that says that people like us that might recommend LEDs to a project, that somehow we're saying to them, Keith, you're an energy hog, and to atone for that problem of being an energy hog, you have to suffer through, poor lighting, like compact fluorescence or something. When in fact it's just the opposite, that LEDs have the ability to deliver better outcomes for us, right? And I'm thinking of the one you talked to me briefly, been months now, about the ability of light to affect our circadian rhythms and help us, actually relax or wake up. I don't want to get too far down this road.
As we're nearing the end here, I'll interject this quickly. This new metric, which has 2 names now. There's one of the versions is called circadian stimulus, and there's another version of it that is called melanopic light, related to melatonin suppression. So, as you know, most of us have this sleep. We have a sleep-wake cycle. It's driven by our exposure to light, specifically bluish light. Bluish light at night and day. Bluish light does 2 things for us. In the morning, our exposure to high levels of bluish light entrains our circadian system. Says, okay, here's the point in the day, and it entrains it, this cyclical system. And then at night, the loss of this blue light allows melatonin in our system to be produced, which makes us sleepy and puts us to sleep, gets us, we go to sleep. So that, so now that has been well documented and studied, and these metrics of looking at it 2 ways. One is the wavelengths of light, their abilities to suppress the production of melatonin. That's one metric that's been out there now.
That's like coffee keeps you awake.
Well, it's the combination of looking at the spectrum of light. How well is it at suppressing your melatonin? And then there's another way to look at it, based on research and the wavelengths that produce melatonin suppression. What is the cumulative effect of the wavelengths of this particular source for stimulating the circadian response? Like what finally gets to the eye, the back of the eye? So there's 2 metrics looking at circadian response. Yeah. But now there's one that has come out from the Lighting Research Center that seems to be a little stronger and is going to be adopted by REACH codes that look at health. And the IES has recognized now that we have become responsible for the physiology, for this physiological response. It's not just illumination, it's the wellness of a person, because if our role is to supply lighting, it's not just so you can work, it's so you can be healthy too. Like, once you know there's a health effect, now you're responsible for it. So now there's new metrics coming, whereas besides looking at illumination, luminance, energy, power and energy, we're going to look at health. And that's going to be a metric that's, we're going to have to put on the table with the other metrics and start to make decisions. So I'm coming around to the end of this, which is you can't do this alone.
Yeah. So
you need an expert. You need someone with experience to do it. You can't, if you want an owner, if you want to give value to the owner, you don't throw LED fixtures in there and say, because we're saving energy. Anything can go wrong. You need to look at these multiple metrics together. And it's difficult. You need a consultant.
So the discussion about circadian rhythms, I think, is actually really important, because I think intuitively we all know that daylighting and natural light, access to natural light through windows or whatnot, is important to our health. That there have been studies the most important ones by the Heshang Mahoney group, correlating higher test scores with students on well-daylit schools or better worker productivity, better retail sales, that we intuitively we know that good daylighting is healthy for us. But it's largely been very difficult to prove why, to figure out scientifically exactly why it is. And there's a common myth that it's daylight is healthy because in our indoor environments because of the vitamin D production. And while it's true that outside the UVB part of the daylight spectrum stimulates the vitamin D production within our bodies, most glazing systems, 99.9% of the windows and glazing systems in our environments filter out the UVB part of the spectrum. So if you're inside all day, even in a fully glazed curtain wall building, it's not going to stimulate vitamin D. So there's something else. And a lot of the studies going on, a lot of the research going on focuses in on correlating us to our circadian rhythms, that by having a view outside, by seeing the shadows on the interior, to see that it's getting darker later in the day, that a cloud went overhead, and those changes are somehow linking us to the world, the greater world outside, and are soothing and more healthy for us. And so it's getting into the how our interior light fixtures like LEDs do that as well. The joke with LEDs used to be that they may or may not be more energy efficient, but they're definitely more expensive. But now that's not always true, right? And we're not sure about the lighting quality. There are some that have great lighting quality and some that are not. There are some that are, usually they're more energy efficient. Frequently they're more expensive. There's other factors involved too. They have phenomenal lamp life, right? So for example, institutions like the University of Texas likes LEDs for the fact that they only have to go service them once every 10 plus years. So it's a maintenance and a facility issue, or the fact that they're solid state. And so if they're in a ceiling fan, for example, I was dealing with incandescence and compact fluorescence with moving parts that would just get damaged by that vibration. So it's great to have an LED just simply so that they don't get damaged by those moving parts. So LEDs, dimming, of course, as you mentioned earlier, Matthew, dimming is a part of lighting controls, which is a big part of energy efficiency, that if we only need half the light, if we have the ability to dim it 50%, with LEDs, we're only using 50% of our power, or maybe even less. With other lighting sources, we may dim it 50%, but we're still using 75% of the power. So like you said, it's a complex environment of all these factors at play. Sorry, I didn't ask you a question there.
No,
That's just more of a lead in.
It's all good. You were saying a lot of advantageous things about LED. I try not to be the pessimist. It's just that many things you said, I've been on projects where those things that sound so nice the end result is they don't work out. Like say dimming for example, just dimming LEDs. You can have flicker. You can have when you dim an LED, it doesn't change color the way incandescent changes color. It gets warmer. It stays the color spectrum stays the same. So now you've got a low level cool light, which may look like strange, like being in an igloo, like light coming in. You're going for this romantic low level light, and it's like cool light, that doesn't quite fit. Or the flicker could cause problems with there was some LEDs flickering to cause seizures. That was a problem. It's the compatibility of the solid state device and the driver and how it's dimmed, and the way that electricity, the way that wave of electricity is being brought to the LED. It's different. The circuitry is different. So there's some compatibility. So all that stuff has, when you actually are on projects, a lot of thought goes into pulling that together. If it doesn't, you're just taking a shot. You're praying it goes right. But yes, if it all works out, if it's all pre-thought and you have a chance to test it, you can get to all these benefits.
Yeah, so I think Yeah, that's a great point, that the potential of LEDs is tremendous. And do you think that we're on the way to that potential, that one day our interior environments will be largely dominated by LED fixtures?
OLEDs, which
OLED,
is the next
OLEDs.
generation. Right. So LEDs are based on rare earth phosphors in them. They're diodes doped with rare earth phosphors that we get from different countries. But OLEDs are organic LEDs, carbon based. Now the difference with them is they can be on films like flexible films. They can be much thinner. So we already have OLEDs in curved screens, curved TV screens, and in our smartphones, but they're still cost prohibitive. They haven't gone through the generations that LED has been going through the last decade, but they're starting to. So if you were to buy an OLED fixture, it's expensive. Like if you want to get a square foot of it, it's an expensive way to light something. But you may want to do it if you're building a space station. If you does money, if you need that light in a thin area, that's what you would use. But it's coming. It's coming. The way that LEDs dropped in price, it would happen with OLEDs. And yes, we're going to move into the point where this room will grow. We could glow. Surfaces will glow the way we want them. We could basically be inside a TV. You can make the room a TV. You could get to those high luminances in small areas. You could pixelate a building inside if you want. You can make it look like, oh, there's a picture of a fixture actually giving me light, where it's an OLED, right? There's a great, so.
Is that the holodeck you're describing?
Well, I think it's the point of just the OLEDs, this thin film. It itself could be the fixture, the film itself. There's so many. If you look at patents about what's being patented now, you probably get an idea of what's coming, because the patents usually come before the actual device, because the technology is right there. So people who are anticipating,
The building science that's in here is implicit in building science 1.0, 2.0, and 3.0. 1.0 being the interaction of building in the environment, right? So like we've talked on the podcast before about, the building needs to be recognized as a physical structure immersed in this massive stream of the atmosphere, like trillions of tons of mass moving by the building. And there's temperatures and humidities and gas phase pollutants and particles. We need to be mindful of all that. Building Science 2.0 is bringing the people into this, which is, and I think about it from thermal comfort. You guys are talking about it from lighting quality perspective. But what's really striking, and you brought this up when you brought up sustainable design, Keith, this Building Science 3.0 is, how do we all work together? How do the three of us as consultants, because right now in this room, right, so I'm a mechanical consultant, you're an enclosure consultant, Keith, and Matthew, you're a lighting consultant, and I guess you're also a lighting consultant. So the point is, getting involved early and getting, just from the mechanical perspective, right, I'm trying and have some limited success, but I tell my architect partners that, look, when you're doing massing on a building, you're defining beauty from your perspective, from your architectural perspective. I very much would like to be doing massing from the mechanical perspective of beauty, being thermal comfort and indoor air quality at that same time. So if you go too far and you didn't let me get my 2 cents in, by the time you show me your thing, here's my beautiful building, I'm like, yeah, what am I going to do with that? Giant, tall, overhangless 25-foot wall of glass, and I'm going to have a client, in their bathrobe first thing in the morning. Anyway, so aperture. For you guys, there's massing, orientation, and aperture, very basic functions of a building. To define those is the design. Don't you want to be in as early as possible defining aperture and shading structure? Right. And it's working. You're getting success.
And it's working. And you do end up with something beautiful, because it's a ordering function that ends with beauty. Mm-hmm. When you design around function, you usually end up with a beautiful form.
That's
something,
exactly right.
And it relates to nature, and then because it's not that we have to be open to beauty, right? That we don't have to be stuck on particular forms. There's lots of beautiful forms, and so if you're designing around visual and thermal comfort, and you're looking at the sun, which is the main source of energy, you're going to end up with something beautiful.
Yep.
So let me just add to that that a big part of our class is trying to teach students to link beauty and performance. We do shading and massing exercises with them, and that really the most beautiful is you can't separate the performance from the beauty.
Yeah.
That if it's beautiful without the performance, then it's superficial beauty and it doesn't last. And it becomes trendy, it becomes out of place.
Right.
And the occupants don't like it. And I believe that designer architect down the line doesn't like it once they sort of internalize how it's not performing. So I believe that's sort of like the key to great timeless design is linking those two things, performance and beauty.
I'm working on some projects now, and so we're establishing prescriptive ways to do things where you follow prescription, and then when there's triggers that appear that say, oh, prescriptive doesn't work, you pursue performance paths, which are simulation. And those simulations are meant to answer particular questions, and the trick is like running simulations that look at all these different metrics at once, because there isn't the software that
You're
does
talking lighting simulations and lighting.
No, thermal too.
Okay.
You know, because there's whole building energy analysis is part of it, because that the underlying energy is one of the big questions too. But so early on, get involved early on, follow prescriptive methods as much as you can, just to get not to spend money unnecessarily on performance too early. Try to see when triggers happen that you come in with performance.
Triggers meaning what?
Triggers that you come across a situation where a prescriptive path doesn't address the full question, and you know that because it's not presented in the simple form that a prescriptive approach would solve. There's more complexity to it. So and it's something you can't really answer without seeing in more depth, which may involve 3D, space-time, and some like looking at something more dynamically, in a methodical way. So it's a performance-based approach. It's a higher level simulation. Maybe you have a 3D model of the building, a weather file of the year, right, by hour,
Right.
and then you're looking at particular things. And maybe you have an automated system, shades that go up and down, and then you add in occupant response. You have an algorithm for how the occupant may drive those shades if it's not automated. I mean, now you're really running a simulation, right?
Yeah.
And there's a lot to interpret. So that's where. So you don't want to do that in the beginning. You want to do that if you have, later if you have to, but. You're trying to approach things simply, right? Simple is better. Simple systems, less complexity. If that works, that's the best way to go about it. So that's part of the answer to this. How do we work together?
So aspiring toward multiple levels of beauty with our project teams is absolutely, I believe, becoming more and more mainstream. And one of the challenges, and this is not really building science, but architects are immersed in our society, and generally all of us in this room, I know, we're experiencing bandwidth constraints with our lives. And so I know that I have certainly had a big sense talking to an architect sometimes, like, oh, they really want to do right, but they're so busy that they don't have time to try to relocate that diffuser for me. I don't know if there's a solution to that. It's not a science.
I think it comes down to priorities, really. And when things are low down, anything, whatever it is, when things are low down on the priority list, they just don't get done.
Yeah.
And so that's something
That's true.
I am hoping in architecture schools across North America that performance can rise up on the priority list, because I think for like a good solid generation or more, superficial beauty has trumped performance, and that's a long topic of discussion.
Oh, yeah.
But I do think it comes down to prioritizing things.
I'm the person that throws in the wrench, that will come up with something. I'm trying to hold myself back more in the interest of doing good, the best business approach too. But when I see things like design-wise, I typically say them. So I can get pretty down and design a path and then see something, and I won't hold it back. I'll say it. And sometimes it gets implemented on a project, but That's the thing. You want to be open. You never want to be closed. Because sometimes the experience of working on something just reveals something. Even things you thought, oh, I really know this. I know the system. But suddenly you realize, oh, I've been trying to do this particular thing, and now I finally figured out what the actual intent was. Let me just frame it that way. So hard to. I don't want to give you an example because it'll keep you open, but stay open through the process. So that didn't answer to your question.
There's always more to say. Thank you guys very much for listening out there. Chances are we'll be looking more into lighting in the future.
Thanks for having us.
Thank you.